All right, hello. We will now have a look at lab number 4. However, before that, I want to show you something really cool, which I totally forgot to set up in the intro and have had in the back of my head for the last 2 videos. However, I just simply forgot it. I want to show you a font with ligatures. As you can maybe tell, my font has changed, and I have activated font ligatures. What are font ligatures? It's basically, you can maybe spot it already if you know what it is. So like, you know how we like have conditions like smaller than equals to. What font ligatures basically do is combine them into one nice symbol, or the equals equals. Wait, what? Oh yeah, okay, smaller than equals equals is like this weird arrow. Apparently this exists, but equals 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 is also a thing. We of course have bigger than equals. It's just font ligatures. It makes the code a little more readable. You can, for example, see it down here. The selection is a bit weird, but in my opinion, it looks really cool. Let me show you real quick how to set it up. So, of course, you need a font family that allows for font ligatures. I have a... Oh, come on, Firefox. There we go. I have a website here that links to a few fonts that support ligatures. I personally am using JetBrains Mono. It is free to download. You can download font, get a zip folder here. Open that, go into the TTF folder, just hit Control A, right click, install. That will install all the fonts. Once you've done that, restart Visual Studio Code, close it, open it again, hit Control comma to open the settings, type in font, click on font here font ligatures, click on edit in settings.json. In the editor.font family, if you are using JetBrains Mono, you will type it in exactly like that. If you're using other fonts, no problem. Just search for fonts here. You can see fonts control panel. And these are the installed font families you have. So for instance, if you type in JetBrains Mono, you see exactly how you have to type it into VS Code. You have to use like these single quotes if there is, for instance, a space. If it's not a space, you don't have to do that. And lastly, the editor.font ligatures is false by default. You have to set it to true. Save the file with Control S, and then you can close both of these tabs, and you should now have font ligatures activated. Okay. I'm going to move my microphone. Mind your ears for a second. All right, that hopefully wasn't too bad. Let's now begin with lab number 4. All of that. Oh yeah, that's a big one. Okay. So session 4, handout, functions, built-in parameters and arguments, Fruitful, and point. I love that name, Fruitful. It's amazing. Okay. 4.1, write a function declaration for a function named a func, which returns a value of type integer and has 2 arguments of type double. All right. We declare our functions outside of main. We have 2 ways to declare a function. If, for instance, you want your main code to be first and all your functions declared at the bottoms, you're just going to declare them empty up here. So if I do it for this functions, int a func and double a double b, these are only used inside, and you just add a semicolon at the end. And then after here, you want to do the exact same. Just paste it basically. Yeah. There you go. Return I because integer, while I is just a variable name. For instance, I don't know what this function does. Let's give it a purpose. So we can say int I is equals to, okay, double is of course a long float. So it is a little stupid. So let me think of how we can actually make a function that works. Oh yeah. Okay. We just declare int I if a is smaller than or equals to b, then I is equals to 0. Oh my god, 0, else I is equals to 1. Oops. There you go. And that would now return I. Simple enough. Yeah. So to put this to a test real quick, we have double A. I'm going to give these other names just so you understand the idea that these down here are local variables. Oops, we don't want double again. There we go, double XY. Printf, please enter double X and scanf long floats and X. Printf, please enter double Y. Where's that bracket from? Oh, that is from the scanf statement. I don't know how it got there. Scanf lf saved to Y. There we go. And then we can say int results is equals to, oh my god, a func. And yeah, you can see that clength already tells you what to do here. So we will pass X. You can tap to the next one and Y. Press tab again to go out. There you go. And even for the functions you write yourself, clength will give you the proper syntax here. So you can actually give these proper names, like, I don't know, first check, second check, whatever. So one warning generated. Oh yeah, because we're not actually doing anything with int result. Maybe we should printf I result. Okay, there we go. Yep, we enter double X, I don't know, 5.9, and double Y would be 5.6, and we get 1. Let's do a little switcheroo, 5.6, 5.9, and we get a 0, as we should. Okay, that as a small introduction to functions and also an overkill solution to exercise 4.1. All right, let's have a look at the next one, which is exercise 4.3. Write a function declaration for a function named void func, which does not return a value. The function should have 2 arguments. The first argument should be a double and the second an integer. All right, simple enough. Let's get all of this out here. So we have void func. First one should be a double, and the second one an integer. And that's basically the function declaration done. Function is declared. We can use it in our code, even though there's literally nothing to it. Okay. Let's have a look at 4.5. Yep, 4.5 is the next one. Yeah, 4.4 is just output tracing. You should be able to do that, lest you just copy the code. 4.5, write a function header for a function which does not have any arguments and does not return a value. Done. Yeah. It is theoretically... Oh, wait. Open that. Okay, there we go. Done. That's how I did it in MATLAB. Also, we don't need stdlib for now, perhaps later. Okay, 4.6 is the next one. Write a function header for a function int to float that takes an integer number as an argument and returns the result in a floating point. Oh, okay, that's a good one. So we of course have floats int to floats. The argument is an integer I. And inside here we have float. Float, I don't know, man. X is equals to I colon return X. That should work. Theoretically, I think return float. Yeah, no, that gives an error. Okay. I was thinking Python in my head again. In Python, this would have been absolutely valid. Okay. Yeah, that's how you basically want to do it. This should be error 3. Let's give this a test. Printf floats of int to float, and we pass 2. Let's run this. Should be 2.0. Yep. Perfect. Okay. Next example. 4.7. Write a function named hypotenuse, which takes 2 double precision floating point arguments at 1 and set 2 and returns a double precision floating point result. Okay. So we have double hypotenuse, and it takes floating points. So float side 1, float side 2. And hypotenuse, like, it doesn't say anything with calculations, but we're going to do a calculation anyways because it's called hypotenuse. So apparently it's using Pythagorean's theorem there. Yeah, theorem. Sorry. So yeah, you know how it goes. A squared plus b squared is c squared. So sqrt of double, also square root float. So we should actually have result double. Result is square root of, and in there we have 2 arguments. One argument is, of course, actually no, we only have one argument. What am I saying? Side 1 multiplied by side 1 plus side 2 multiplied by side 2. Okay, we are getting an error with square roots. Let's hover over that. Call to undeclared library function square root with type double ISO C99 and later do not support implicit function declarations. Fix available. What is the fix? Quick fix is control period. No code actions available. Splendid. Include math.h. Yeah. So you can just right click here. Non-void function does not return a value. That is just a warning, not an error. So this code will still compile. Yes, we of course want to return result. Yeah, square root x should be, this calculation should be fine. I don't know if C does PEMDAS, but it definitely does do brackets. Well, we'll see if it does PEMDAS. As for here, do we do this with input? Nah, let's not do this. Let's just check it real quick. Printf, long floats, and we have the hypotenuse of, let's do 2.5. And 3. Let's run this. Yeah, you can check if this result is correct with your calculator, which is actually a good idea. I should do that. So we have the, where even, square root of 2.5 squared plus 3 squared. 15.25. Take the root. 3.90512. Yada, yada, yada. checks out. All right, perfect. Also tells you C does pandas. Yep, that would be the hypotenuse function with actual working code as probably intended by the person writing up this document here. Okay, the next one is homework 4.8. Write a function named largest, which takes 3 integer values a, b, and c and returns an integer. Okay. Int largest, int a, int b, int c. And we have, okay, we gotta do, actually, this is rather easy. So we have if a is bigger than b and a is bigger than c, or actually we have to put this statement in brackets then. And we have a second statement if a is bigger than b and a is equals to c, or if a is bigger than, no, if a is equals to b and a is bigger than c, we return a. Else if, and we are going to increment this. So now we would do the same checks for b. So if b is bigger than a and b is bigger than c, or b is bigger than a and b is equals to c, because we're not excluding the possibility that some of them could be equal, or b is equals to a and b is bigger than c, we return b, else we return c. There we go. Else should be either they're all the same or c is the biggest. So let's put this to a test. Int a, b, c, printf, enter a, b, and c separated by a space, and we do scanf integer, integer, integer into a, into b, into c, and we printf an integer largest a, b, c. Okay, that should be it. Not getting any errors indicated here. So let's do 1, 2, 3, 3. Let's do 3, 2, 1, 3. Let's do 1, 3, 2, 3. Let's do 3, 3, 2, 3. 2, 3, 3, 3. Yeah, okay. I think this should be working. I hope you understood all of these conditions up here. I think they are formatted in a way that they should be understandable. If you don't understand these conditions right away, just try to write down all of the conditions on paper. You can, of course, do a lot of if checks. I try to combine them as much as possible. So basically this if you could split up into 3 separate ones because we have the bitwise OR statements here. Yeah, each of these checks if A is bigger than B and C, or if A is bigger than B and equal to C, or if A is equal to B and bigger than C. That would mean that A is the biggest value, or B and C, but A is still the biggest because it shares that spot. We do the same thing for B, and if that isn't true, then C must be true. And I do believe that is also how I did it in here. Oh, wow. Okay, interesting. In my own homework, I actually had a different algorithm, you could say. So in my homework, I just had if A is bigger than B and A is bigger than C, return A. Else if A is bigger than B is bigger than A, B is bigger than C, return B. Else if C is bigger than A, C is bigger than B, return C. Else return A. That is another way you can do it, I suppose. This here works as well. Certainly you have your own implementation. Experiment a bit, learning by doing. Okay, we also have a 4.9. So let's continue on. Write a program which uses a function to calculate the square of a user-entered number. The function should take the user-entered number as an argument. Okay. Doesn't say which kind of number, so I'm just going to do this as a double, which takes a double, and we just call that value, and we return value times value. So I don't know. We have double input printf, please enter a number to be squared, scanf, long floats into inputs, which uses a function to calculate the square of a user-entered number. Okay, yeah, that's basically what we're doing. So double squared is equals to square of inputs printf long floats \n squared close brackets, and that should be that. So I don't know, 5.5. Let's not do it with a comma. 30.25 seems about right. If not, oh well. No, it is right. Also, you can add the 2 decimals here again, or any decimals you want. And you just get 2 decimals. C does round correctly, so don't worry about that. Next one is 2.13. Let's see. 4.30, my bad. Yeah, 4.10 is trace, 4.11 is trace, 4.30. What? Oh yeah, 4.12 is, yeah, okay, correcting errors. Okay, 4.13, write a program which uses a Fibonacci function that uses a loop instead of recursion to print the Fibonacci series. Oh, that's an interesting one. Okay. It is supposed to print, like the function is supposed to print the Fibonacci series, mind you. So it will not return anything, thus it is a void function. So we have void Fibonacci int, say amount, like the amount of times to print it. So we have int series. We are using an array for that. Well, I'm using, I'm just copying this from my homework. Arrays were not yet a part. Should I do it with an array? I don't know. Actually. No, I don't think I need an array. No, we do not need an array. So for int I equals, and we start, of course, at 0. I is smaller than amount, and I is incremented by 1. We print f. Oh my lord, yeah, I have made my own code incredibly complicated. Oh, good lord. Okay. Well, amount, if the amount is 0, obviously we will not print we will not print anything. So for I0, yada yada yada, if I think the first thing we should do is print f0, because that's where the Fibonacci series starts. I see now why I did that with an array. We will come back to this once we talk about arrays. I should probably take a note somewhere, but I don't have a pen, so I pray to myself that I don't forget it. Actually, I'm just going to open a new tab in Firefox and Google array lab do Fibonacci. There we go. Weird thing to have in my search history, but it's a note for us to do it later, because I think this is an excellent example on how to work with arrays. Anyways, continuing. So we actually, before we print anything, there are 2 conditions to be met. So the first entry of the Fibonacci is 0, then we have 1, then we have 1, then we have 2, then we have, I believe, 3, then we have 2 plus 3 is 5, then we have 3 plus 5 is 8, then we have 8 plus 5 is 13, so we kind of need to work with that algorithm. Thus, we have already printed the 0, so we start with I is 1. We increment I as long as it's lower than amount. Lower or equals to amount if we start at 1. So actually print f. If amount, if amount is greater than 0, that's a check we should do, because if amount is 0, we can't really do anything. So yeah, close that bracket, increment all of this. So yeah, only if the amount is greater than 0, actually doing something. So we start printing the Fibonacci series, and I do it as long as I is less than amount. So if I is, like, if amount is 1, it won't do anything. The 0 is already printed. So we have to int. Int is last entry and current entry. Last entry is equal to 0. Current entry is equal to 1, because that would be the first entry, and this is the first iteration of this loop. So, and of course we also have a temporary variable to deal with. So now we can print f. Actually, temp is equals to current entry. Last entry is equals to current entry. No, wait. Okay. Current entry is equals to current entry plus last entry, and now last entry is equals to current entry. There we go. Then we print f%i space current entry, close the bracket. And that should be, if I'm not mistaken, the Fibonacci series. Let's figure out if this... yeah, I think this should actually work. Never mind, it doesn't do anything. Int amount, printf, enter an amount of entries to print from the Fibonacci series. Close that, scanf for an integer saved into amount, and we call Fibonacci file Fibonacci amounts. Okay, now we should have a working one. So let's say we run it 0 times, nothing happens. Let's say we run it once, we get 0, 1. That should, of course, not happen. Int starts at 1. If amount is bigger than 0, we print that. Int I equals 1. If I... Oh, okay. We need to delete the equal if I smaller than amount. So if we just do it once, we get the 0. If we do it... Okay, let's have 10 entries of the Fibonacci series, see if it actually checks out. 1. Okay. That is just binary. That is not the Fibonacci series. Oh, lovely. Okay, let's see where I went wrong. So our temporary entry is our current entry, which is, of course, 1. Then the... okay. Wait. Let's take all of that. Let's cut all of that. Put it below the printf statement. So we print the current entry. Current entry plus last entry. I just hope, like, that's a bit weird. It's still binary. But it does the double one as it should. So it should, of course, calculate 2 plus 1 to get the 3. So temporary entry is equals to the current entry, which here is 1. Current entry is current entry plus last entry, which sets the next entry. Am I doing this correctly? I hope I'm doing this correctly. Wait. What if I... temp. Currently last entry. Oh. Oh. I see. Current entry is already changed, so last entry will be the same as current entry. We, of course, need to set that to our temporary value. That's why we needed a temporary value to begin with. There we go. That is the Fibonacci series. I will quickly compare this to the code on my laptop, just to be sure. Okay, yeah. Perfect. Perfect. Okay. There you go, Fibonacci series. That took embarrassingly long, but I do remember that it took me equally long to code this in the first place because I'm not that good with algorithms, mathematical stuff like that. So let's quickly move on to the session 4 exercises. I got sheet 4.1. I don't know which one you got, so let's get rid of our function. Get rid of everything in our main, and let's do this quickly because my dog is in front of my door and wants to be let out. 1. Write a program that prints out the largest of 3 entered integer numbers. A secret function in find max has to be implemented comparing the values of 3 integer variables x1, x2. Can be assumed that the values are different pairwise. The function shall return the biggest value of these. The input of 3 integer values as well as the output of the biggest value should be handled by the main function. Don't use global variables. I've basically shown you that one earlier. So yeah, I can tell my exercise 1.c is literally just what I copied over. But I'm just going to use this really quickly to show you the different quote-unquote algorithm. So we have int find max, int a, int b, int c. And here we have if. Thank you. That tabbing was not at all helpful. I just wanted this to be here. So if a is bigger than or equals to b, and a is bigger than or equals to c, we return a. If, nope, not, oh my god. Else if b is bigger than or equals to a, and b is bigger than or equal to c, we return b. Else if c is bigger than or equals to a and c is bigger than or equals to b, we return c. Else return, let's tab it nicely, return a. There you go. That is basically the algorithm I've used before, and the inputs you already know, obviously, because we've handled that earlier as well. So let's have a look at the final exercise 2. Write a program that converts a decimal number n into the corresponding binary number with 5 digits. Use a function d to b int n in order to convert the decimal number n into a binary number. The calculated binary number should be printed out by the function. The function should return no value. The program shall ask the user for the number n. The allowed range for n is between 0 and 31. If the user enters a value for n which is not in the allowed range, the message n is out of range. Please enter a number between 0 and 31 should appear. The input of n and the range of the range checking should be handled by the main function. Note that the function d2b does not need to be able to handle numbers bigger than 31. Therefore, you can keep the algorithm relatively simple. Example, the user enters 26. We get the result 11010. Algorithm principle for conversion of 26. Yeah, you, of course, already know that. So I can't be bothered to pull this from the top of my head. So let's do this later. Before we write the function, let's just do the input handling. So we have int number and of course int attempts for our input handling, because yeah, you know why, we went over this earlier. So print f, please enter a number to be converted to binary. I pray to God that I'm doing this with arrays again. Why am I like this? Why am I like this? God damn it. If number is smaller than 0 or number is bigger than 31, printf n is out of range. Please enter a number from 0 to 31. Okay. And of course, attempts plus plus if attempts is equals to 3, we terminates, and we of course need stdlib.h, s for math.h. We don't need that actually. And we do that while number is smaller than 0 or number is greater than 31. And then we call d2b of number. Now let's define void d2b int x. Okay, let's figure out how I can actually do this. I'm creating an array of size 5 while the rest is unequals to 0. Then I'm looping through the array backwards. Okay. Yeah, I got this. I got this. So theoretically, if we think about this, we're doing remainder division by 2. So we can say int x0, x1, x2, x3, and x4 because we have 5. Yeah, we have a 5-bit number, so we have x0, 1, 2, 3, 4. X0 is equals to the remainder we get when we take x, the remainder division by 2, and do that a total of 4 times, I believe. X1 should be 3 times. Or is it 5 times? We'll see. X2 is equals to x divided by 2 divided by 2. X3 is equals to x divided by 2. And x4, damn it. Okay. Right. 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 This is not how you do it. The smart ones among you, so basically everyone except me has already figured this out. So 1, 2, 4, 8, and 16. 1, 2, 3, 4. Yeah, these are the binary numbers we have. So x0 is equals to x binary division with 16. x1 is equals to x, not binary. Did I say binary? I meant remainder division. Sorry. Remainder division with 8. x2 is x. Remainder division with 4. Don't forget the semicolon in both instances. x3 is equals to x. Remainder division by 2. And my clock is ticking. I am x4 is equals to, well, I mean, it can't be x. Let's have a look at the algorithm example on this sheet. Yeah. Oh. Right. Okay. Never mind. We have to work with the rest. Stupid me. So this is the rest of the division by 2. Then x is equals to x divided by 2. x1. Third time's the charm. Also, we start from the most significant bit, that being x4. And x is equal to x over 2. x2 is equals to x remainder division 2. X is equals to x divided by 2. x1 is equals to x remainder division by 2. X is equals to x actually divided by 2. And last but not least, x0 is equals to x remainder division 2. We don't need to divide x again. So we print f %i, 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 %i 5 times. And we do x5, x4, x3, x2, x1. Close the brackets. 1, 2, 3, 4, 5. And we, of course, do 4. Actually, x0. This should be the algorithm. Let's test it with 26, 0, 1, 0, 1, 1. That is not the algorithm. Actually, it is. I've just printed everything backwards. 0, 1, 2, 3, 4. Now the 26 is correct. Yeah. I know. Let's do 27. It should be the same, but with 1 at the end. Yeah, there we go. Okay. Let's do input validation. Actually, 0. Okay, 0 prints all zeros. That's fine. -1, of course not. 32, of course not. 33. Yeah, and it terminates. This isn't even an algorithm. It's just basic calculations. You could do this with a for loop, but I've already had 2 attempts at this, so I decided not to. This is one way to do it. I think the next topic is arrays. At least I hope it is. In which case we're going to revisit both of these examples. But yeah. Bit embarrassing. Anyways, see you next time.